Hello and welcome to another yearly past paper session. Today I am going to solve 2024 S2 exam. This is the variant 6-1. Let's begin with the first question and see what it is. I have the marking scheme open in front of me. I will check answers as I solve. The first question says the heights of a certain species of deer are known to have a standard deviation of 0.35. A zoologist takes a random sample of 150 and finds the mean height of the deer sample is 1.42. Calculate 96% confidence interval. So mu will be z x bar minus z value into sigma divided by root n x bar plus z value to sigma divided by. Okay. X bar is simple. It is 1.42. What is the z value that you're going to take? 96% means that I need to leave 2% on both sides. So I'm going to go on and read 98% from my normal distribution table. Let's see if I have the normal distribution table in front of me. I think I had the formula sheet open somewhere. If I come across it, yes, okay. So 98%, it's not directly on the table, so I will have to calculate. So 9798 and plus 2, so this should give me 2.04. Oh, sorry, 2.054. Okay, so 2.054 sigma divided by. Okay. That is giving me 1.4786. I think the significant figures should be 1.48, and this one is giving me 1.36. Check if these are correct. Correct. Bouvet says that 96% of the deer species are likely to have heights that are within this confidence interval. Explain briefly whether Bouvet is correct. No, it simply means that the true population mean will be in this confidence interval. The 96% chance. Okay, correct explanation. No, CIE is not about mean confidence. About mean, then not about individual. My reasoning is more or less correct for similar mean both. Okay, the masses in kilograms of small and large bags of wheat have the independent normal distribution this and this. Find the value or find the probability that the total mass of 3 randomly chosen small bags is greater than the mass of 1 random. Probability of 3 randomly small bags is greater than the mass of 1 randomly. So I'm going to move this to one side first and say 3s minus L is greater than 0. So the difference is called 3s minus L. This is a question on more than one observation. So I'm going to say that the mean is going to be 3 times 16.0, so minus P1, and the variance is going to be 3 times 16 minus 51, 3 times 0.4 plus 0.9. There's no subtraction when we talk about variance. Calculate that. Minus 3 and 1.2 plus 0. Okay, so z greater than 0 minus 3 divided by root of Probability of z greater than 2.07. 1 minus 5 2.07. 1 minus 5 2.07 should be 0.9808. 1 minus 0.019. Let's check if that is correct. Yeah, it is correct. The time t minutes taken by a random sample of 75 students to complete a test were noted. The results were summarized as this: calculate unbiased estimates of the population mean. So unbiased population mean is simply sample mean 230 divided by 75. 46 over 15, which decimals is 3.07. Okay, 46 over 15, I'm going to remember that for the next calculation. The unbiased variance is n over n minus 1 into s square, and s square is basically the sample mean. So this is going to be 75 over 74 into 930 over 75 minus 45 over 70. 46 over 15 minus the mean squared. Okay, 275. 3.04 variance. 3.036, 3.04, and 3.07. Yeah, both of those answers are correct. We should now assume that the estimates from part A are the true values of the population mean and variance of t. The times taken by another random sample of 75 students noted, and the sample mean t bar was found. Find the value of A such that probability of t bar is greater than A is 0.234. So the sample, if the population mean was 3.07 and the standard deviation variance is variance question. Yeah, variance is 3.04. Okay, so t bar will then have the distribution 3.07 comma 3.04 divided by 75. Okay, so z greater than a minus 3.07 over 3.04 divided by 75 in a root is equals to 0.234. 1 minus phi of a minus 3.07 over root of 3.04 over 75. Okay, that is what is going to happen. I think I have enough space here to move here. That 1 minus 0.234. .76. Okay, this is phi, so I'm going to put a phi inverse. Okay, phi inverse of 0.76. 0.766 needs to be reversed. 742. And then I probably need 18 on this. 0.726. 0.726. Okay, so root of 3, root of 4. 3.22. 21. I think my answer is more accurate. Why that's a problem, but they've taken, okay, no, they have taken 3.0667. 40%. Minus 3. Let's just do it this again. 3.04 divided by 74.72. So that gives me 3.21. So the bottom line is that I should have taken a more accurate version, but I've not taken a more accurate version of this, so I'm not sure what's going on there. But the marking scheme tells you that. Okay. Then question number 4 says a random variable x has probability density function f defined by this, where a is a constant, show that a equals to 27 over 2. Okay. So I will integrate over the entire function and call that equals to 1. So ax minus 2 plus 1 divided by minus 1 divided by minus 2 to 3. Okay, so minus a over 3 and plus 9 over 9, minus a over 2 and 9 over 4. So minus a over 3 plus 1 plus a over 2 minus 9 over 4 equals to 1. So a over 6 gives me 9 over 4, and therefore equals. Okay, that turned out to be a longer question than I wanted because I made a calculation mistake. Let's move on. Show that expected value of x. Okay, so let's start with expected value of x. So this makes x f of x from 2 to 3. Okay, a has come out as 27 over 2, so that gives me 27 over 2x squared minus 18x cubed. Okay, let's first multiply, so that's going to give me 27 over 2x minus 18 over x squared. I still have to integrate that, so this becomes 27 over 2 ln x minus 18x power minus 2 plus 1 divided by minus 1, and then I put my limits. Okay, so 27 over 2 ln 3 plus 18 over 3 minus 27 over 2 ln 2. I will have to manage with this only. Plus 18 over 2. Okay, so 27 over 2 common, ln 3 minus ln 2. That gives me ln 3 over 2. And 18 over 3 is 6. 6 minus 9 gives me 1. I think that's the proof of calculation for me to go ahead with. Question number 5. The length in centimeters of a worm of a certain kind are normally distributed with mean mu and standard deviation 2.3. An article in a magazine states that the value of mu is 12.7. Scientist wishes to test whether the value is correct. He measures the length x centimeters of a random sample of 50 worms of this kind and finds that uh, sum of x is 597.1. He plans to carry out a test at the 5% significance level of whether the true value is different from 12.7. State whether the reason he should use a one-tailed or a two-tailed. Two-tailed because he wants to test for a change. He wants to test for a change in the value. Okay, so h naught is mu equals to 12.7 and h1 is mu is not equals to 12.7. I didn't check my answers to the previous question. Go on and check quickly. Oh, those were prove that questions. That's it. Let's go on and uh, do the test. I will have to draw the critical region at the 1% significance level. I think percent significance level means 0.5% on both sides. So I'm going to test for 99.5%. 99.5% is 2.576. So 2.576 and minus 2. So z value of test statistic. What is my test statistics? He found that 597.1. So x bar must be 597.1 divided by 50. 11.942. What's my z value of test statistic? 11.942 minus 12.7 divided by which is 2 to the 50. Giving me minus 2.33. Okay, so minus 2.33 falls here. So I can say that except H naught, there is not enough evidence to say that it has changed. Check if that is the correct. Okay, yeah. Question 6. It says the numbers of customers arriving at server desk A and B during a 10-minute period have the independent distributions, this and that. Find the probability that during a randomly chosen 15-minute period, more than 2 customers will arrive at desk A. Okay, more than 2 customers will arrive in a 15-minute period. This is the 10-minute period. So desk A has lambda A is 1.8 for 10 minutes. So for 15 minutes, lambda A will be 1.8 divided by 10 and multiplied by 50. That gives me 2.79. Okay, I think now so more than 2 customers. 1 minus probability of 0 and 1 and 2 as well. So 1 minus e power minus lambda minus 7 e power minus lambda minus e power minus lambda in 0.7 square divided by factor 1 minus e power 0.506. Okay, let's check if that is the correct answer. Okay, next question. Next part, find the probability that during a randomly chosen 5-minute period, the total number of customers arriving at both desks is less than 4. So, 5-minute period. So, let's half the lambdas. That's going to be 0.9 and 1.05. So, 0.9 and 1.05. Lambda A and lambda B for um, 5 minutes, and that gives me a total of 1.95. And in that chosen, I want the total number of customers arriving is less than 4. I want the probabilities of 0, 1, 2, and 3. So e power minus 1.95 and 1 plus 1.95. I'm writing the summarized form of this that I can calculate quickly. Although if you have the white calculator from Casio, you can probably do this directly. I am going to do actually directly on my calculator by going into Poisson, cumulative distribution, then cumulate. Okay. If you don't know what I am doing, there are videos on my channel that will help you solve the problem. It's 6. Okay. That should be the correct answer. Yes. And says an inspector waits at desk B. She wants to wait long enough to be 90% certain of seeing at least one customer arrive at the desk. Okay. Uh, Find the minimum time for which you should wait, giving your answer correct to the nearest minute. Now, lambda is 2.1 for 10 minutes. Since I don't know for how long I have to wait, so lambda is 2.1 divided by 10 multiplied by t for t minutes. Okay, so it's 0.21 t for t minutes. Now, she wants to be at least 90% certain of seeing at least one customer. So she wants at least one customer. She wants to be 90% certain. So this is 1 minus probability of 0, 9, 1 minus e power minus lambda equals to 0.9, 1 minus 0.9 into e power minus lambda. Then take an ln, then of 0.1 equals t. T is then 10.964. Nearest minute would give me 11 minutes. Okay, I hope that's the correct answer. Last question. The number of accidents per year on a certain road has the distribution Poisson lambda. In the past, the value of lambda was 3.3. Recently, a new speed limit was imposed and the council was right. Typical question whether the value has decreased. Okay, so 3.3. I want to test whether it's less than. Okay. The council notes that the roll number of accidents during 2 randomly chosen years after the speed limit was reduced, and it carries out a test at the 5%. So for 2 years, lambda should have been 6.6. Okay. Find the probability of a type 1 error. Now, probability of type 1 is basically trial and error. So if you are testing for less than, what you would start with is I could start testing for x is less than or equals to 1. I would accumulate the probabilities of 0 and 1. Okay, if I find those probabilities to be less than 5%, I'm going to try to come as close to 5% as possible. Let's check. Okay, this is very easily done with one of the calculators that can do Poisson directly. So I'm going to use that. My calculator has that feature, so I'm going to use that. So lambda x is 1 and lambda is 6. My probability is coming out to be 0.0103. That's very small compared to 5%. I'm going to increase my critical region and say that I now want to do probability of 0, 1, and 2. I already have 0 and 1. Let's just write down 2 and then accumulate it. And that gives me 0.0399. Now I will also have to check if it can be less than or equals to 3. That gives me 0.105. Okay, so that's significantly greater than 5%. This was the closest to 5%. So this is the critical region. The critical region is x is less than or equals to 3, and the probability of type 1 is the probability of the critical region, which is 0.03. Okay, given that x equals to 2, carry out the test. So the null hypothesis is lambda equals to 3.3. Each one is less than 3.3. For x equals to 2, 2 is in the critical region. Probability of x less than or equals to 2 is 0.0399. Is less than 5%. Reject H naught. There is evidence that number of accidents has decreased. Okay. Part C. The council decides to carry out another similar test at 5% significance level using the two hypotheses and two differently randomly chosen. Given that the true value of lambda is 0.6, calculate the probability. So the probability of a type 2 error is simple then. Type 2 error is probability of acceptance region. Acceptance region is going to be, in this case, the opposite of the critical region that I found. Critical region was less than or equals to 2, so the acceptance region is x is greater than or equals to 3. Now, when I'm doing this, I want to calculate the probabilities of 3, 4, 5 up till infinity. But I'm going to now use the new lambda that I have. What is my new lambda? The lambda is 0.6. I am going to do 0, 1, and subtract it. And I'm going to use the new lambda. You have to show me this amount of working, even if you're doing with the calculator on the exam. Okay, because the examiner is going to want to see all of this working. Point 0.0231. 0.2. Okay, I hope that's the correct answer. Um, oh, I missed out on the fact that this was supposed to be 2 years. 2 years forgotten, so fix that. My bad. .121. Okay, the last part says using the lambda equals to 0, 6 and a suitable approximate distribution, find the probability that there will be more than 10x in 30 years. So lambda equals to 0.6 for 1 year, lambda equals to 0.630 for 30 years. Lambda is large, so 3 is 18, 180 and 1 decimal place, so 18, 18.0. Lambda is large, so instead you use a normal distribution. What probability? More than 10 accidents. So you first do a continuity correction and say 10.5, and then you convert it to 10.5. The mean is going to be 18. The variance is also going to be minus 1.76 minus 1 minus 5 minus 8, 7, 9, 6, 5. Okay, yeah, 2. So one silly mistake in the entire exam, which I made in the previous part. In fact, there were 2 silly mistakes. I made a mistake when I was calculating in the continuous random variable question as well, but a rather short paper too. Thank you for watching. I'll be back with another.
Welcome to Edge Learning, where we are changing dreams into success stories. Let's go! At Edge Learning, we offer courses to help you excel. Whether you're preparing for the SAT, aiming for IBA and LUMS, need O and Olevel tuition, or IELTS coaching, we have the right program for you. Forget about boundaries. We offer learning anywhere, anytime. Our expert tutors provide personalized attention in various batch sizes and one-on-one sessions, along with pre-exam review workshops to ensure you perform your best on test day. Join us at Edge Learning and take the first step towards turning your dreams into reality. So what are you waiting for? Register now or call us.